Hey everyone, this is the Math Nexus, and today we are going to start with exercise 2.3 of O level and IGCSE additional mathematics. So, before I start with this chapter, I want to just tell you a new concept that would be coming in this exercise. And the thing is, as you can see here, this is a modulus graph after it is reflected. Initially, it was around something, if we have a direct reflection of this, was something like this, and then we reflected the graph because it was in a modulus, the quadratic equation, and we had something like this. So the thing is that on different altitudes, we are going to have different um, solutions. For example, when we talk when x is lesser than, so sorry, when y is lesser than 16, this is 16. Okay, whenever y is lesser than 16, we draw a line somewhere, it's going 1, 2, 3 and 4. We are going to get 4 intersections, meaning we are going to get 4 solutions for when y is equals to 12, and that would consequently mean that we would have 4 x values. We would have some x value here, we would have some x value here, we would have some x value here, and some one here. There are 4 x values. So that would mean for different altitude. So whenever the y value is lesser than the y value of the minimum or the maximum point in terms of in terms of a modulus graph, we would only get a maximum value. So I can say whenever the y value is lesser than the maximum point y value, meaning 16, for example, here, not necessary for all the others, it could be 12, it could be 2, it could be even 0.5, it depends on the equation and the graph. So I'm just taking this example in consideration, right? It's the example from the book. So whatever y value is lesser than the maximum point, it is going in terms of a modulus graph after it is reflected. It is going to have 1, 2, 3, and 4 solutions. Whenever the k, or you can say the y value, is lesser than the maximum y value, we are going to have 4 solutions. And another thing is, whenever that y value is equals to 0, we are going to get 2 solutions because these 2 points are intersecting at this point. So when x is equals to 0, so we can say that only when y is equals to 0, we are only getting 2 x values, and this applies for every modulus graph after it is reflected. Okay, so we are getting 2 points when y is equals to 0 at this point. Okay, another thing, what is the another thing? Another thing is that when we have the point exactly at the maximum point, the y value is passing through that point, then we would have 3 solutions, one here, and one at the maximum or minimum point. So we are having 3 solutions when it is passing through the maximum y value. So one is the stationary point, one is the where quadratic graph after it was coming from the negative x-axis, and one is towards the starting of the quadratic graph. So there are 3 points whenever we take in consideration the y value at the maximum point or the stationary point. Okay, so and another thing is that whenever we take a y value that is greater than a stationary point in a modulus graph, we are only going to get 2 solutions, one here, one here. And by the way, again, 2 solutions means different x values. So for 4 solutions, we are getting 4 x values, 2 solutions, we are getting 2 x values, and so on and so forth. So that was a basic concept. We are not going to see this for now, but I was just thinking it was my duty to explain it because it's a new concept and you should know it. So y is equals to the modulus of x squared minus 4x plus c. Okay, so this is question number 1. And the thing is, what they've told us is to sketch the graph of each of these functions. And as we can see, this is a quadratic graph and this is going to have a modulus. And the thing is, it's really important to visualize first of all. And as we can see, this is a quadratic equation. We get in our mind this graph is going to be something like this or something like this. But with the coefficient of x squared, we got to know, okay, this is only going to be a smiley face. It's a positive coefficient. The second thing we see is it has a modulus. So that means if this is the x-axis, then the graph is going to be reflected. And we can assume now that our graph is going to be something like this. And it's when we visualize some things, it's really easy to sketch the graph, to plot the points, to find the points. It's kind of a trick. I'm going to, this is really a helpful trick, by the way. So just leave it for now. Now, the thing is, what we do is whenever we want to sketch the graph of our modulus function, which has a quadratic equation, what we do is take the when x is equals to 0, when y is equals to 0, and we have to take the midpoint of the x values. So why do we have to take the midpoint? Let me get to that point. So the thing is, for example, we make a really rough graph. Okay, a graph is something like this. We have the quadratic equation, we get this graph from it, and we have to reflect it back. And for that, let me just make this something like a dotted graph. Okay, and we have reflected this back from this. So this is a modulus graph, as we can see. Okay, the thing is, we can notice here that we are getting two solutions for x when y is equals to 0. And the thing is, we know that the stationary point of a graph occurs when it's exactly in the half. So we can say between these two stationary points, if we just find the exact half, for example, it's here, it's the exact half. We find these two midpoints, we get the midpoint of the x values, and when we go exactly down, we are going to get the stationary point y value. So we can easily find the stationary point. We already have the x value through the midpoint, and then when we input the x value into our equation, whatever it is, it may be x squared minus 2x minus 3. So when we input that, we are going to find the y value. So we can say that the key for finding the stationary point in these cases is the midpoint of the x-axis. And obviously we want a coordinates, different coordinates for our equation. So that's why we are going to use when x equals to 0 and when y is equals to 0. So these are the three things we are needing. So let's jump straight in. When x is equals to 0, y is equals to modulus of 0 minus 4 plus 3, and that's going to be, okay. For the other part, when y is equals to 0, x squared minus 4x plus 3 is equals to 0. X squared. Okay, and now what I'm going to do is I'm going to use a calculator. Okay, we are getting two x values, x is equals to 3 and x is equals to 1. What we are going to do is now find out the midpoint for our graph. So MP, midpoint of x, or you can say that's the stationary x value. So 3 plus 1 divided by 2 is equals to 4 divided by 2, which is equals to 2. So that's 2 is our midpoint. And what we're going to do next is when x is equals to 2, y is equals to x squared, meaning 2 squared, 4 minus 4 to the 8 plus 3, 4 minus 8, 4 minus 8, negative 4 plus 3, negative 4 plus 3, y is equals to negative 1. So we have the points, what we are going to plot. So we have 3 0, 1 0, we have another thing 0 3, and we have 2 and negative 1. These are our points. And by the way, I have not done a modulus onto them so that I can draw the full graph. You can also apply the modulus on the first place, but I find it easy when I'm applying all of the things in one place. So what we are going to do is take line tool. So for the second point, we are going to, when x equals to 1 0, 3 0, 1 0, y is equal to 3, and then we have x equals to 2, so y is equal to -1 somewhere here, and we can reflect the graph back wherever we want it to go. So we are going to connect these with our curve. We're going to go at this point, pass like this, something like here. By the way, that's a wrong thing. It's passing through this point. Okay, good here. And then and then over here, and that's it. So this is the basic graph, and what we are going to do is mark the point 2 and +1, because that's where we are going to get our answer. So because it's a modulus, so it's going to pass through this point like this. Let me see. Wait a second, please. Oops. It's like here, passing through this one. Oops, again. I hate drawing curves. It's really bad. Oh my god, this. I mean, it's really hard to draw a curve in your virtual graph paper. Something like this. Yes. So this is our graph. Let me show this. This is our graph. So we have completed the requirements for question 1. We are going to now proceed to part B. So I'm going to do this very quick. Let me first erase this point. Okay, and let me just clear this up a little bit. Yeah. Okay, for part B, what we are going to do is write down the equation y is equals to x squared minus 2x minus 3. And again, first find out when x is equals to 0, we are going to get y is equals to 0 minus 3. And when y is when y is equals to 0, x squared minus 2x minus 3 is equals to 0. For the time being, I'm not going to take the modulus in consideration. So again, I'm going to use the calculator. 1 minus 2 and -3, and we are going to get 3 and -1. So x equals to 3 and x equals to -1. We are going to find out the stationary point. 3 plus -1 is going to be 3 minus 1 divided by 2. That's going to be 2 divided by 2, and that's going to be 1. So when x is equals to 1, y is equals to 1 squared minus 2 minus 3, and that's going to be -5, -4. So we have our points. Let's just plot these coordinates on a graph. Okay, so what I've done, I've plotted these points on our graph, and what I'm going to do is find out when x is equals to something value near to what we have found out for the negative value, so we can have a starting point for much more easier communication. So we have -1 as a point. I'm going to use -1.2 because this is essentially a large graph. So -1.2, -1.2 squared is going to be 1.2 squared, 1.44, and minus 4 multiplied by -1.2, that's going to become positive 4.8 plus 3, and if we add these up, plus 3 plus 1.44, we are going to get is equals to 9.24. Okay, so we are going to have another point, and x equals to -1.2, y is equals to 9.24. So I'm going to go upwards. 9.24 is approximately 9.2. 1.2 is here, and it's going to go somewhere like, hey, this one is good. So let me use this 3 here too, and that's it. So what we are going to do next is connect the points on our graph. It's really easy, hard to show rulers. Let me just yeah. So that's good. We are going to connect this curve from this point to this point and then merge them down somewhere like here. So, and that's it. Again, it's going to go somewhere like this to one, if I am not wrong. Sorry. Let me connect these points somewhere like this. Please wait a second. That's it. And we can say from here we don't need as much. That's it. And then what we're going to do is make a reflection of the below. So when x equals to 1, y is equals to positive 4, we are going to make a point at that. Connect these points. Again, for this part. And that's it. So this is our graph for part B. As you can see, that's it. Let me erase this first. That's it. Okay. For part C, what we have a similar equation. We're going to say y is equal to x squared minus 5x plus 4 is our equation. Let me disconnect this. Y is equals to x squared minus 5x plus 4. So what we're going to say is y is equals to, sorry, when x is equals to 0, y is equals to 0 minus 5 plus 4. Sorry, 5 multiplied by 0 plus 4. That's going to be positive 4. And when x is equals to, sorry, when y is equals to 0, x squared minus 5x plus 4 is equals to 0. Similarly, what we are going to say is mod sort of 5, 3 equation, and 1 minus 5 and 4. You're going to get, according to this quadratic equation, x equals to 4 and x equals to positive 1. So what we do next, we find out the midpoint. So 4 plus 1 divided by 2 is equals to 5 divided by 2, which is consequently 2.5. So that's our midpoint. And when x is equals to 2.5, we have to find the stationary point y value. So 2.5 is squared. 2.5 squared, 6.25. And what next? Minus 5 multiplied by 2.5. 5 multiplied by 2.5, it's going to be 12.5. 12.5 plus 4, and that's going to be 6.25 minus 12.5 plus 4, and that's equals to minus 2.25. What we are going to do is plot these coordinates on a graph. We are going to get when 4 and 1, let me correct this, 3 and 1 and 4 are our first coordinates. Then we have again y x equals to 0, y is equals to 4, this point. And similarly, when x equals to 2.5, y is equals to negative 2.25. So at this point, we're going to go down, and that's going to be somewhere like so. So that's it. These are our coordinates. We are going to connect these like this, that, connect this up here. I think I did not bring that beautiful curve for this one. Let me just make that one. That's it. Similarly for here, make a similar curve. Okay, you could have extended this, but we do not know the coordinates right now. And in fact, I'm going to find the coordinates. So when x equals to 5, y is equals to 5 5 is 25 minus 5 4 is 20 plus 3, and that's going to be 25 minus 20 is positive 5 plus 3 is 6 7 8. So we are going to go all the way up till 8. That is a little bit too much, I guess. Let me check this again. So yeah, I took the wrong equation. My bad, my bad. So when x is equals to 5, we are going to say x squared 5 5 is 25 minus 5 multiplied by 5 is 25 again plus 4, and that's going to give y is equals to 4. So when x equals to 5, y is equals to 4 again. So we are going to connect these points if we can. Something like this, yeah, it's going good. So this is a graph for part C. I think that's enough for today. I'll meet you in the next lecture with exercise 2.3. Thank you.